Hey everyone, a very warm welcome back to the channel. Now today we have a very good question from Maxima Minima and it is related to geometry. The question says an ellipse inscribed in a semicircle touches a circular arc at two distinct points and also touches the bounding diameter. Its major axis is parallel to the bounding diameter. When the ellipse has the maximum possible area, its eccentricity is how much? So this is quite an amazing question and it is a PYQ of kvpy and time allotted would be maximum 10 minutes. Ideally, you should try to do it within 3 minutes. So let's see, the answer to this question would be under root of 2 by 3. Now the method of solving the question relies on the fact that we should know a method of finding global maxima, where we also need to consider the endpoint values and the values at critical points, and comparing them, we can say which of them is the global maxima. Parametric equation of normal to the ellipse also we should know. Now, the figure here is self-explanatory. What's happening is that we have the circle S, we have the circle, we have the ellipse E, and it is touching the circle at two distinct points P and Q. It is also touching the bounding diameter, which is at the point M. And obviously, since the major axis of the ellipse is parallel to the diameter, the only point where it can touch the bounding diameter is the center because of obvious symmetry. So the ellipse, now what we have done is we have also introduced coordinate system. So the major and minor axes of the ellipse have been assumed to be the x and y axis, and the center has been assumed to be the origin. So that's why ellipse equation would simply be this. Now for the circle S, center would be M and radius we have assumed to be R. R would obviously be a constant or fixed quantity because in reality in the question we are given a semicircle, right? But I have forcefully completed it into a circle anyway. And of course, this semicircle is going to be fixed. What's not going to be fixed is ellipse. The ellipse is a variable ellipse, which we have to maximize the area of, right? So clearly, what we are given is the semicircle. What we have to maximize is under the given restrictions is the area of the ellipse out of all the variable ellipses that can touch the circle in the given ways. So out of all these, area whose we have the maximum, that one we'll consider. Now they must have, since they both the ellipse and circle touch each other at the point P, they must have a common tangent, let's say T, because that is very obvious. If we have any two curves and they are touching each other, then by definition they must have a common tangent at that particular point. So at P they will have a common tangent T, so they must also have a common normal, which we are calling as normal N, and it must pass through the circle center M. The reason is, whenever we have a circle, right, and we draw any tangent, then at that point, if you draw a perpendicular, which is actually the normal to the circle, it must obviously pass through the center of the circle, a very basic fact. So M's coordinates would obviously be 0 comma minus b, because it is the end point of the minor axis of the ellipse. So now let us do one thing. We can assume P to be a cos theta comma b sin theta, because it obviously lies on the ellipse also. So we have just assumed it to be some kind of a point in parametric form. Now at this parametric point, we can write the equation of normal to the ellipse, a very standard result. Now since M satisfies it, because look, the normal N is obviously passing through the point M, right? So M would have to satisfy it. So 0 comma minus b I have substituted in here, and finally we are obtaining sine theta equal to this quantity, which we are calling as equation number 1. Now MP would be equal to R. The reason is MP is simply the radius only, simply the radius of the circle, right? So MP is equal to the radius R, which is a fixed or constant quantity, as we have already discussed. Now squaring both the sides and applying distance formula between the points M and P, this is the equation that we are getting. Cos square theta we can write as 1 minus sine square theta, and then I can factorize this as 1 minus sine into 1 plus sine. And from both these quantities, we can take 1 plus sine theta as common. So inside we would be left with this quantity, and this is equal to R square. Now sine theta, we already know from equation number, its value what we have, right? So that I substitute in here. So 1 plus sine theta comes out to be this quantity. And here we have simply opened up the brackets and taken and written it like this. Now this quantity would obviously be b square from equation number 1 again. So b square minus b square would become, just cancel out each other, and a square would be left. product would be a power 4, cross multiply, so a power 4 is equal to this quantity. Now we can just separate the b square term out and write it in terms of a and r alone, which we are calling as equation number 2. Now area of an ellipse is obviously given by a is equal to pi ab. So since we want to maximize this quantity, we basically can say a square b square needs to be maximized, but a square b square can be written as this quantity. The reason being, b square I have substituted in from this equation number 2. Its value, if I substitute in here, obviously this would become this thing, which needs to be maximized. But b square is obviously greater than 0. It has to be. So this thing is greater than 0, but that would mean that from here I can write r square a square minus a power 4 must be greater than 0. Or we can say this thing must be greater than this thing. So r square a square greater than a power 4, cancelling by a square, we get a square must be less than r square. So a square, if I let it equal to t, then obviously it would be greater than 0. Any square quantity cannot be negative, but it must be less than r square because we have already proved it. So range of t we know. Now we have to maximize this function, right? This function will become f of t, which is t square minus t cube upon r square, because a square we have substituted as t. Now f of 0 if we find and f of r square if we find, both of them you can easily see they will come out to be 0. If you put 0 here, 0 only, and r square if you put here, we will get r power 4 minus r power 6 upon r square, which is again r power 4, so 0. Now endpoint values we have found. Now we find the derivative and equate it to 0 to find the critical points, so that we get t is equal to this quantity. Now f of this quantity comes out to be this quantity, which is obviously the maximum value out of 0 and this quantity, because once we have the values at critical points as well as the endpoints, we simply compare them to find the global maximum. So this is clearly the maximum one. So this is going to be the correct answer for the maximum area. But we are not being asked to find the maximum area. We are being asked to find E, eccentricity E in that case. So no problem. T, which is equal to a square, must be equal to this, right? So that's what we have substituted. But what was the equation number 2? Equation number 2 said b square is equal to blah, blah, blah. So what I'm doing now is I'm simply going to substitute in the values. So b square, I have written as this quantity. Once again, I'll try to explain. What I've done is I've simply substituted a square value as 2r square by 3. And doing that, we are getting b square as this. Let me explain a little bit more. So from here, I can say b square would be equal to a square, but a square is obviously 2r square by 3 as we have derived below, and minus a power 4 by r square. So its square again we'll have to do. So 4r power 4 by 9, and upon r square will make this r square again. On simplifying this quantity, we simply get 9 in the denominator, and above we are getting 6 minus 4, which is 2r square. So that's why the value of b square is 2r square by 9. So obviously e square would be equal to 1 minus b square by a square. B square upon a square, clearly if you substitute in these values, will come out to be 1 by 3, which is 2 by 3. So e comes out to be under root 2 by 3. So quite an amazing question, and this is our final answer as well. I hope you all enjoyed watching it. Make sure you like the video, comment down below what more you would like to see next, and share it with your friends. Subscribe to the channel, hit the bell icon to never miss an update, and I'll see you all in the next one.